I do want to stick a little bit on the idea of nonlinear springs. And to do that, I want to talk about vibration case study 1.2, and that's adjustable vehicle suspension. I think it's like a 2019 model. This is a Volkswagen Golf GTI. I think it's like a 2019 model with a 6-speed. And so the question about this in a vibrations class, right, is how do vibrations interact with us kind of on a daily basis? So a lot of, or every car manufacturing company or every credible car manufacturing company will have a division in their design team called noise, vibration, and harshness. NVH. And the goal of this team is to look at how they can make a car that is more comfortable to ride in, right? So with the proper understanding of NVH, engineers can design cars that can adapt to their surroundings. And that's something that they've tried to do on this GTI. It's a little hard to see, but there's a button right here that allows you to select different vibration modes. You can have I think it's comfort, normal, and sport. Now let's think through as a vibration designer what we might want to prioritize in comfort, what we might want to prioritize in normal and sport, or at least comfort and sport. So in comfort, I probably want to isolate you from the ground vibrations that are picked up by the tires running over the road as much as possible, right? Because the more I can isolate you from the ground, the more comfortable your ride will be. However, that has drawbacks such as body roll increases. You're not going to be able to feel different amounts of pavement or different changes in the pavement that if you're really kind of driving a sports car, which the GTI pretends to be on some days, you might really actually want to feel that, right? And so on a sports method, let's get rid of as much damping as possible. Maybe not all of it, but let's get rid of a good chunk of it. And we're going to stiffen up the suspension at the expense of letting more vibrations through into the passenger component, into the passenger compartment. We will give you a better feel of the road, maybe stiffen up the suspension or take some damping out of the suspension and the steering. All right, if you were to say, put an accelerometer in your cup holder, hook it up to a data acquisition system, hook it up to a laptop, run a bit of LabVIEW code, you could drive down the interstate, just kind of the same portion of interstate over and over and over, take 5-minute data, take data for 5 minutes, and then of that, you can run what's called do a frequency analysis to look at the frequency of the data. And so we did that for this car, and let's see what it looks like. And this is what that data looks like in those 3 different modes. What I first want to focus on is this time domain data. What's super interesting about this is the sport, normal, and comfort. Okay, maybe sport's got a peak at -2 meters per second. This is just running straight down the interstate, right? So it's not doing any churns, anything fancy, same speed, cruise control. But it's mostly between -2 and 2 for sport, normal, and comfort, right? I mean, objectively, in this amount of the data, the comfort actually has the highest acceleration value. But is that what we actually feel, right? You feel acceleration to some component, but when you're sitting on a seat, you are going to feel different levels of vibration at different frequencies. And that frequency component is actually what's more important, right? So you can feel higher level vibrations, but let's just focus on the low frequency. So everything below 5 hertz. And what we did here is ran a frequency analysis. This is the same data, but instead of looking at it in the time domain, we look at it in the frequency domain. So this is kind of the amount of energy at 1 cycle per second, 2 cycle per second, 3 cycle per second, 4 cycle per second, 5 cycles per second, and we call that hertz. And we'll go into this more in the class in detail later. But right now, what I just want to point out is that the sport mode does not dampen out your low frequency vibrations, right? It is significantly higher than your comfort mode, which is this green line down here. And then the normal mode is in the middle. And so, as someone who has ridden in this car, I can confirm that this is what that car feels like, right? You really feel it in sport mode. Whatever it does with the suspension, it stiffens it up and does a few other things. You can really feel that it connects you to the road. In normal mode, it feels quite comfortable. And in comfort mode, there is a small difference between normal and comfort, and it does feel a bit more comfortable, but not a huge difference between normal, but there is a big difference between normal and sport. So the goal of this class, right, is that an engineer like yourself could use the knowledge of the single degree of freedom, 2 degree of freedom systems you learn in this class to design better products, such as an automobile or an airplane, and the functions that that can function well for multiple use cases, right? What's kind of cool about the GTI is that it can be a very comfortable car, and it could also autocross if you want, right?